Well, this project's actually about trying to look at what it is in some of these anti-methanogenic plants that we're so interested in that actually causes the reduction in methane. So we know that the plants do it, but these plants are a complex mix of compounds, and we know some of them are actually causing this reduction in methane, and we're very keen in this project to not only identify what they are, but by doing that it gives us the ability to see how they're working. We know that we'll find compounds that reduce methane in the rumen, I'm sure of that, but what we're hoping to find is that there's not just one compound that's doing it, but there's actually a number of different compounds. So it's a little bit like having an antibiotic or a drench. It's best to have a variety of these things rather than just a single factor that's responsible for the effect. And so I think that we will find a number of these compounds that are responsible, and that gives us more armoury, if you like, to try and get persistent effects. Yeah, it's really quite a fundamental part of the work in discovering the compounds and the mechanisms by which they operate. So it seems a little bit basic and fundamental, but in fact it's a key way in which we can have a marker that assists us to manage shrub-based systems or different systems that include anti-methanogenic plants. And part of that in a bigger picture is that these shrub-based systems are a way in which we're trying to enable producers to cope and capitalise. So cope in the bad seasons and then capitalise in the good seasons by giving a little bit of flexibility in the way in which they operate. So we want to do that, but at the same time we are trying to juggle that balance between productivity and the methane that's produced. And understanding a bit about the compounds helps us with those management practices.